Hello, class. This is Mr. Bean, AP Physics, homework simulation number 4, vertical motion. So let me go ahead and kind of slide this over here and let's see what we got going on. So we'll go over here and we're going to do high school toss level 1. And I'm not sure why we have this over here. Let's get rid of this. And so what we're going to do is go ahead and click on this link here, and this comes up here. So it looks like Thanos already did it, so it can be done, but Thanos was able to do it. So let's go ahead and refresh this and kind of see how we might approach this problem. All right. So the school is located on a planet that is not Earth. So you got to be very careful that you don't use 9.8. You'll be asked to determine impact speed of the object, the maximum height that the object obtained from the surface, and how long it was in the air. Go ahead and click on begin here. And here we go. So a high school is 9 stories tall, and a small 2.9 kilogram object is tossed upward from the roof with a speed of 24 meters per second. The ball will land on the ground at the base down here. The acceleration due to gravity on this planet is 10.68 meters per second squared. Each story of the school is 3.13 meters tall. What's the total flight time? What is the impact speed of the object? And what's the greatest distance the object is ever above the surface on the planet? All right, so when we do this problem here, a couple of things to think about. So um, let's go ahead and kind of think about this distance right here. Maybe we can call this here like maybe delta little h to show the height above the ground here. Okay, height above the ground. And we know here that G is going to have a value of, where are we at here? G is going to be 10.68. So 10, we'll say 0.68, okay, meters per second squared. Okay, 10.8 meters per second squared. And and VO, initial speed. So I'm going to draw a vector like this here. And we're going to say that the initial speed VO right here is going to be, what is it? In this case here, it is 24 meters per second. So I'll go ahead and put down here 24 meters per second. Okay, going upwards here. And so what's going to happen is take a look and see what's going to happen. The ball is going to take this trajectory here, right? And it's going to come like this, and then it's going to come straight down like so here. And we want to know what is the speed right here, right before impact. So this is one of the things that we want to be able to find out here. And then what's the total time in the air? Okay, so what I would recommend is breaking this problem into two parts, two distinct parts. Okay. Okay. Now, since the ball is being tossed upward, we will take. Let's go over here. We'll take up here to be positive. Okay. Therefore, going down is going to be negative. Therefore, G here is going to take on a negative value, negative 10.68, because it's going downward. Going down is negative. All right, so that's kind of the problem here. Okay, so here we have this delta H here. Okay, so we want to find out how high is the high school to begin with. So over here, let's go ahead and kind of write down what delta H is. So delta H is going to equal, let's see what we got here. It's going to be 9, there's 9 stories, right? 9 stories. And each story is 3.13 meters. So 3.13 meters is going to be delta H. So that's our starting height right here. That's our starting height. Okay. Now, this part right here, see this, this here, maybe let's go ahead and call this delta Y. So this will be delta Y, and delta Y is going to be the height that the ball reaches and to the top of the building here. Okay, that's going to be delta H. So Let's consider two parts of the problem here. Let's go ahead and consider part one here is, we'll call it, okay, toss up. Okay, let's call this the toss up. Okay, so toss up. Okay, let's see what we can find out about this upward motion here. Okay, so a couple of things that come to mind here. So it looks like we have a couple of equations we might be able to use. So the ball is going to go up here, then it stops right here. So at this location here, we know the final velocity here is going to be zero. It's going to be zero. Okay, so we have here v, the final velocity, equals here is VO, right? Here's VO plus, and so I'm going to write GT for right now, but I know it's going to be negative, so we want to be careful. And we'll say time going up. U means going up. Okay, so we can put some values in here. So this is going to be zero here, right? The initial velocity is going to be what, 24 meters per second. It's positive because it's going up. Now here, I'm going to go ahead and write in here minus, because G is negative 10.68. So negative 10.68 is right here. Okay. And then from times T up, T up. Okay. So from here, I should be able to find the time up. Okay. And this will be the time it takes to go up. Okay. So that's going to be T up. Okay, and we know what T up is going to be. Yes, T up. Okay, now what else? Can we find this delta Y based on the information we have right now? What is this delta Y? So let's take a quick look here. Let's see what we might be able to use here. I think we can use V squared, right, equals VO squared, right? We'll say minus, I'm going to put plus for right now, plus 2g, right, delta y, 2g delta y, 2g delta y. So again here, the final velocity is going to be 0. The initial velocity we know is going to be 24, but it's got to be squared, right? 24 squared, right? Okay, and we put minus 2, right, times 10.68. So yeah, 10.68 right here, right? 10.68 here, point here. And we'll call this here delta y. Okay. So from here, we can find out what delta y is. So from here, we'll get a value that delta y equals something. Okay. And we'll be able to get that value right here. Okay. So now we have delta H here and we have delta Y. So we'll call big H the total height. Big H, the total height. It'll be composed of two parts, delta H plus this delta Y that we just calculated, this delta Y. All right, so that gives us delta H right here. That gives us the total height that it ever reaches, okay? And we also have the time up, the time going up, okay? Now, at this point here, this is a brand new problem now. We'll call this part two. We'll call this here part two. So part two means the ball is the ball is here, and VO now is going to be 0, right? Because it's at rest at the very top up here. This is going to be 0, and it's going to drop all the way down to the bottom here. And we want to know is what is the speed, what is the velocity right here at impact. Okay, so VO is 0. Okay, but we do know the total height is h, right? The total height is h. That's from where the ball starts from, right here, or the object. The total height is h, and so we need to find two things. What is the time going down, right? And what is the final velocity upon impact? Okay, both very good questions. So now let's take a look at the final velocity. Let's take a look at final velocity here. I think we can use v squared, right? V squared equals, we'll say here, VO squared here, right? plus, we'll say here 2 g, we'll say here h. That's our height here, right? Now, in this problem here, since we're starting going down, now this time we're going to say that going down is positive. Okay, therefore G will have a positive value. So going down is positive. Over here, going down was negative. So here, brand new problem is going down. All right, so from here, I think we can calculate what V is. This is going to be 0. We know what G is and we know what H is. So here, we should be able to calculate what the final speed is upon impact. Okay, then the last part here, we want to find the time down. So we know the final speed or the final velocity here. We know the initial velocity is going to be 0 here, right? Plus, and we're going to go ahead and do here, this is going to be GT, right? There's GT, okay? And we'll call it time going down. So we know what this velocity here is from here. This is going to be 0. We know G, we solve for time down. Therefore, the total flight time is going to be nothing more than the time going up plus the time going down. Okay, and that should be your total time. So go ahead and do this and go ahead and get your Thanos on, and we'll go ahead and meet again on simulation number 2.